So hi folks, today we are going to review a paper, a deep learning approach to contract element extraction. This paper has been published by Ilias Chalkidis and Androutsopoulos. So what's the gist of paper? So basically, it, the paper focusing on the extraction of particular entities from a large unstructured text. So the paper mostly emphasizes on legal data in which we have contracts and there are certain information which are essential to be extracted. So let's just go into a summary. So they have this kind of information they need to extract from legal text like termination date, legislation, references, contract parties. There are total 11 type of such kind of elements which are present there. Now let's go into the paper. So what they're doing is they have built their models and they are comparing it against the previous work. So previously what they were using is they were using a sliding window by using logistic regression or SVM, and they compare the output and they've seen that the current method is outperforming the previous method. So what's the current method is? So let's discuss. So what they're doing is basically they are evaluating on the basis of three different kinds of models. These are the models. So what's happening here? So first of all, they are not working on all the unstructured data. They are working on specified zones, which they think as a hot zone. Like the probability of finding the elements is more that zone. And for the LSTM model that they've used, they're using Glorot initialization, Bandit Centropilus, and Adam Optimizer. Apart from that, they have used three variants models of LSTM. First one is a BI-LSTM LR extractor. So it's a combination of BI-LSTM, logistic regression as a dense layer. The second one is a stacked model, which contains BI-LSTM downwards, then LSTM layer, and then LR layer. And the third one replaces this LSTM and stacked LR layer with a CRF, condition random field. So it is pretty much there. So let's just dive deep, what's happening. So I'm going to show you this image, and probably from here you can just make the gist out of it. Uh, this is probably the timestamp which are representing. They are representing three timestamps. So let's go into the first timestamp. What they're doing is they are feeding a word and then they are computing a feature out of it. I'm going to discuss the feature later, but suppose right now we have 230 feature per token. So they are using a hidden state of 300 dimension. So this is a forward LSTM, this is a backward LSTM. So when we combined the forward and backward states, we'll end up having 600 hidden states. So after that, they are applying a logistic regression model, and after that, they are just predicting the result. Similarly, in this case, in this case, we have a forward layer and forward layer and a backward layer, LSTM layer, and then we have a stacked, this hidden LSTM layer here between. And after that, in third model, which is not shown here, they just replace this with CRF. Okay. So what's happening here? So basically, this is a sequence classification problem. So we are taking a document as input, and we are classifying each word what type of token this word is. So we are not making a multi-class classification problem. We have 11 different models. So each model is working on a different field. So for termination date, we will have a different model. And when we are, working with the model, the first word, when the first word comes, we are classifying as yes or no. And then second word, we are labeling as a yes or no. And third word, fourth word, sixth word, similarly like that. So that's the just what's happening here. So now let's dive into features. What the features are used here. So they are using a 200-dimensional pre-trained word embeddings, basically over to X. So each token, like a word, like payment is a word, it will be converted into 200-dimension vector. And the next set of features is they are using a post tag embeddings. So again, 25-dimensional post tag embeddings. And there's another 5-dimensional feature. So which they are using is these are the seven different variations that are used. The first one is any word which contain uppercase letters and also include and may or may not include hyphen and dots. And similarly with the lowercase letter, which might include hyphen and dot. The third one is any word which contain an init cap. The initial letter is capital and then followed by lower letters. And the fourth one is related digits. The fifth one is the line break, and sixth one is non-alphanumeric, and seventh one is any other token. So these are just embeddings used there. They haven't used any handcrafted feature. That's the gist of using LSTM, that you don't have to use handcrafted feature. Now, let's go back into paper. So basically, that's the overall gist. So what they're doing is, so this is the first experiment. So second experiment is a third experiment. Uh, Now they are evaluating. The evaluation is done based on two criteria. First, they are matching per token wise. Suppose if we are, labeling this whole paragraph. Suppose if you're trying to label the whole paragraph and we say group of experiment, as our labeled entity that we extracted, means we are labeling group as one, of as one, experiment as one. When we are doing evaluation per token, we'll treat each token as individually. So these three will be considered as three true positive. And the second one, in the second one, we are taking where's the second one? Evaluation per contract element. So in the second one, what they're saying is they're counting this as a single case, and then they are making their F1 score based on that. So if the whole experiment match, then that's okay. So that's the whole algorithm that they've used by BI-LSTM with the CRF, the third model. So now it's time to compare the result. So what they are showing is that they have different type of models, like three models are there. BI-LSTM, logistic regression, BI-LSTM, LSTM, logistic regression, and BI-LSTM with CRF, and the other one is a logistic regression, and this one is a SVM model. So when they are showing the result, they are trying to say that the LSTM-based approach clearly outperformed the existing approach. Like the CRF is actually giving a better results in some of the cases, whereas the LSTM logistic regression layer is giving better results in some of the cases. This is the F1 score. So yeah, that's pretty much it, I guess. So I guess this is per the contract element type. I mean, this must be for the second part, relation per contract element. Similarly, you can see the majority hold here. So yeah, that's all, guys. Okay, all right, guys.